So this is about exception safety. So the thing that throws an exception here is this statement. Right? But you see it opening a file before, and then it acquires some global mutex. And if this throws an exception, then this code is never executed. So the mutex is still locked, and the file is still open. And if you have a long-running server process, that means this can lead to a deadlock, and this just, if you like call system or like execute some other program, then this file is still open in the context of the other code, which can be really bad if you like set your ID or something. So this is a security problem. It's not just bad, this is a security problem. And this happens mostly in wrapper code in C++. If you wrap code from other languages, mostly C. And if you look at typical C++ programs, that's like what most of the libraries do. It's just wrappers around some other stuff. Right? So this is a problem. It may not look like it hurts you, but it does. And so about the delete operator. In normal cases, so what most people do with arrays in C++ is they just use an array of int, or usually it's a char array, like for old string interoperability, or it's a wchar array for wide character manipulation. And if you do that, then this is just the same. If you call the bracket delete operator or not, that does the same, because the members of this array are just ints and they don't have a constructor or destructor. So in the typical case, which is probably the only one you will ever see, this is no problem. But if this is some kind of class you defined, then suddenly this delete also calls all the destructors for the elements in here. So how does it know how many elements are in there? It's a question, you know, until someone asks the question, you probably, oh, right. So how this is done, the font is probably a little small, so I wrote the C code equivalent here. So what it basically does is that the pointer you get is not actually the pointer it allocated, but it's plus size of an int. And there's an int in the first 4 bytes, or like how big the int is on the platform, that says how many elements the array contains. So if you pass this to the wrong delete operator, then it tries to free an address that doesn't come from malloc, but it's inside the block. So if the attacker can say what kind of data is in there, then you lose at this point, right? And the other way around is also bad. So if you, that's really the easy case, right? If you call delete and you, this by the way also crashes if no attacker is there. So this is not very, this is a rare thing, but it can happen in some error handling cases that are usually not executed. So this actually, you can actually see this in real world code, but it's rare. And the other way around, if you call the array delete operator and it's not actually, you should have called the non-array delete operator, then it will read an int from before the array and try to call some destructors. And if the class has virtual members, then it will go to the vtable, and that could point somewhere, and it calls some pointer somewhere. So you lose too. So this is a security problem too, right? The integer overflow is subtle, so the example I'm giving here is this. So let's say you use wchrt, and someone gives you an n that is this huge number. So let's assume 32-bit for now, right? So in this case, what this does, it takes n and multiplies this times size of the size of each member. And this is what the compiler does. This is inline code generated at this point. Then it calls a regular operator new that just gets a size in bytes. And what that one does usually is just call malloc, right? So if you give this a value that makes the times size of wchrt overflow lead to 0, like in this case, then the operator new is called with 0. So this is a typical textbook integer overflow, but you don't see any multiplication or addition here. So this is another one of those stealth implicit stuff happening behind your back. So this, actually all the compilers I know except MSVC still fail for this. MS Visual Studio fixes the bug, and I'm sorry to say it's my fault because I reported a couple of bugs to them, and the guy said, oh, I know someone in the compiler group, and so they fixed it. But on most other compilers, including GCC, still fail on this. There's a subtle thing I'm going to mention, because the fix they have is that if there's an overflow, they just set the value they pass to the new operator, the overloaded one. They set it to -1, like the biggest value they can possibly represent. And so if your operator new is overloaded and adds like 10 for the small header in the beginning, then suddenly this is really bad, right? even if you circumvent the check, really. So this is the stuff. You should really see Lisa's talk if you're interested in this, but I give you the basic idea. So if you have this function and you have a static member and it's not just an int, but it's something that has a constructor, then this constructor should be called the first time this function is called. Right? So what if you have two threads both calling the function at the same time? And you can see how the compiler does this. They have this guard variable that's red, and if it's 0, then we haven't done it yet, so this is not thread safe, the code the compiler generates. This is actually GCC 3. GCC 4 fixed this, but you can see the subtle problems arising from the standard being too powerful. So I promised this, but it's also quite easy. So you have this, you have a class bar, it's a base class, and you have a class that's inheriting from bar and has more members. And now you have an array of them, like this pointer here somewhere, and you can pass this array, although it points to bar pointer, to a function exploiting, although it is a foo pointer, you can pass it to a function expecting a bar pointer because it's a base class. So this will happen, but if the function does more than use the first element, then this is done by adding the size of one struct bar and not one struct of the actual size of an array. Because it's not known, this function doesn't know it, it's just operating on the base class. And you can see that if the code is complex enough, this can bite you. So this is really the last slide I have. I found this quote from Bjarne Stroustrup where he says, this linker problem I mentioned that all the virtual functions pull in all this crap code you don't need. And he said, whole program analyzers should be used to fix the problem. And this is a really hard problem, so he's basically proposing to solve a variant of the halting problem, and he's saying this should be done, and we should use the virtual function tables, and we should look at the type information, and so my thinking is that this is done really a lot of times in C++. That people say, oh, in like a year or so we have better tools, and then this problem will go away. And this particular quote is like a couple of years old, so I'm not seeing it happen. So I'm expecting Nukem forever before this happens. So that's all I have. I hope I could get some impression to you how C++ can bite you. I'm not saying that other languages are better, but you should at least be aware of what you're using. Thank you.